Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2115. Find all possible recipes from given supplies. This question is based out of graph theory and it has been asked in almost all the tier 1 companies like Google, Amazon, Microsoft, Uber, Adobe, Bloomberg. It's marked as medium. And okay, let's just try to understand the problem statement first. You have information about n different recipes. There are n recipes. And you are given a string array recipes and a 2D integer array ingredients. For ith recipe has the name recipe I and you can create it if you have all the needed ingredients from ingredients I array. They are also saying that a recipe can also be an ingredient for other recipes. This is very important. That is, ingredients I may contain a string that itself is a recipe. Now you are also given a string or array supplies containing all the ingredients that you initially have, and you can have infinite supply of them. This is the initial set of ingredients, maybe spices, whatever, raw material you have to prepare recipes, and then one recipe that you have already prepared that can be used as an ingredient to prepare another recipe. Then return a list of all the recipes that you can create. You may return the answer in any order, doesn't matter, and note that two recipes may contain each other in their ingredients. Okay, recipe A require an ingredient B and recipe B require an ingredient A. It means they are saying that there can be loops in this system. If there is a loop, we can't prepare that recipe. Impossible to prepare. Okay, now just have a look on the inputs given to us. First one is a recipe array. These are having string array, and for every recipe we have ingredients. This is the array of ingredients. The recipe array and the ingredients array size are same, so it's a valid input. Bread can be prepared using yeast and flour. So these are the ingredients for first recipe. And now if you have a look, these are the ingredients for second recipe. But here if you try to analyze, this itself is a recipe. So to prepare a sandwich, first of all we have to prepare bread and then we'll be preparing sandwich. And what is the supplies? This is the initial set of raw material you can consider. Let's say now this is the problem statement, and if I ask you, if I just remove one part of this problem, that a recipe can be an ingredient. Let's say a recipe cannot be an ingredient. In that case, what we are going to do? We have a recipe and these are the ingredients. We will just check whether that ingredient is present in the supplies or not. Whether we have that ingredient or not. Because it is also given that the supplies of these items are infinite in number. If these are infinite, it means any recipe prepared using these items are also infinite times. So this is our input. Recipes, we have to prepare ingredients required for every recipe and supplies that is infinite in number. So initially we have that yeast, flour and meat infinite number of times. So yes, we can set a flag, yes, we have these three items present. And now if I just try to prepare these items, bread, I will see all the ingredients of that bread. Bread have all the ingredients. They are indexed same index. Like bread is at 0 index in recipe, so ingredients are at 0 index in ingredients array. So bread is having yeast and flour. Both of these are present. Let's say this array is something like available items or available prerequisite nodes, raw material. So bread have everything is present in this. So yes, I can prepare bread using my supplies. So for that I have to maintain a list, and that list is going to have a list of all the recipes. Bread I can prepare. But here if I can prepare bread can also be used as a raw material for other recipes. So I might have to add bread in this as well. Yes, we have a supply of bread as well. We have an infinite supply of bread because we have all the raw materials. We can supply bread as well. Now when I come to sandwich, I'll go to the same index. This is the same index. Sandwich require bread and meat is available as a part of supply, and bread is also available because in the previous call we have created bread. We have created a bread, so bread is also available. So in this case, sandwich will also be the part of this answer array. Correct? Let's say my recipes are something like this. Recipe is A, recipe is B, and A is dependent on some raw materials and B is dependent on some raw materials along with A. Correct? And there is another recipe C. So C is dependent on B. So to be able to prepare B, we should have A prepared first, and to prepare C, we should have B prepared first. This is not always one level. This can keep on going. This nested. A is dependent on B. B is dependent on C. C can be dependent on D. In this case, we definitely have to go recursively because let's say in recipe A has a couple of ingredients. We just have to check whether that ingredient is present in this map or not. If it is not present, if it is a recipe, let's say A is dependent on this, and I was trying to see whether I can prepare recipe B or not. B is going to check all the ingredients. First ingredient, yes, let's say this is present, this is also present, and it is dependent on A. A is a recipe. A is also present. But if instead of this B, if I just check C first, whether B is present, either this is present, this ingredient is present, yes, this is also present. B is a recipe. B is a recipe. So we firstly know that okay, this is a recipe or this is a supply in material. B is a recipe. So what we have to do is we have to check nestedly that whether I can prepare B or not. Can I prepare B? B will be coming to A, and then A will let us know that okay, can this be prepared or not. And while preparing this, if there is a case arise that say D is dependent on A. If D is dependent on A, it is a sort of cycle. Cycle is getting formed, and if the cycle is getting formed, the recipe is impossible to prepare. So topological sorting, when we have studied the topological sorting, we studied that okay, first of all, there is no cycle. That is a requirement. If there is a cycle, then we won't be able to finish up everything. You won't be able to finish recipe C because that is dependent on D. D is dependent on A is dependent on B. Will keep on going the infinite loop. So for that, to keep track of that, first of all, we have to go with recursion, and then we also have to keep track of the visited nodes. Now let's try to think in terms of graph. Now what is a graph? Graph is, let's say, collection of vertices. Let's say we have 3 vertices, and apart from that there is edges going from U to V. U is dependent to V. Let's say this is 1, 2, 3. 1 is dependent to 2. 3 is dependent to 2. This is a graph. In this case, our sandwich, first of all, you should understand that these supplies are our raw material. Like our recipe is dependent on supplies, and recipe itself can behave like an ingredient. So let's say if I just call everything as an ingredient, yeast, flour, bread, sandwich, flour, meat, everything is an ingredient, and that ingredient is a node to my graph. First of all, node is bread is dependent on yeast and flour. Bread node is dependent on yeast and flour. After that, sandwich is dependent on bread and meat. Sandwich is dependent on bread and meat. This is sandwich. You might not read it, but this is sandwich. Okay, this is the graph, and now this look like this definitely look like a graph. So whenever there is a graph, we need to keep track of the adjacency so that we will be able to track over this graph. Firstly, the requirement is you should be able to think of what is a node in this case. Now this node is ingredient and recipe. Recipe itself is a node and ingredient itself is a node. And ultimately what we have to figure out is, can we prepare that recipe or not? See, recipe will always be dependent on some other recipe or ingredient. So just consider recipe as a node. So let's say the node is dependent on these three nodes. 1, 2, 3. Can I prepare this? Can I prepare this? Can I prepare this? So this is something you have to figure out. If this is a recipe, it will be dependent on a couple of more things. If these are ingredients, no, they are not dependent on any other things. If these are dependent on these three, just go nestedly. And if you are visiting, let's say this is A and this is B, and you are visiting A again, there is an infinite looping. You are stuck in a loop, and then this recipe cannot be prepared. So in that case, that is a false. So you have to think in this manner. Prepare a graph. Graph is of like any node is dependent of how many nodes. So in this case, the sandwich is dependent on how many things. See, if you just try to have a look, this is a node and this is dependent node, neighboring nodes, node and neighboring node. Let's say bread is dependent on yeast and flour. What does it show? It shows that it is already an adjacency. B is dependent on Y and F. And sandwich is dependent on B and M, bread and meat. Okay, this is also adjacency. Adjacency means we can visit, we can get to know all the neighbors in order of one time, and we can go to all the neighbors in a constant time. Sandwich is dependent on bread, and the bread is dependent on these two things. So I get to know that okay, sandwich is dependent on bread. And how do I go from this to this, from bread to all the ingredients of bread? Just taking another map. Another map means, let's say I have a bread. If bread is a recipe, I should be able to go to its ingredients. So what we can do is, I can maintain a map, a recipe to index map. Recipe to index map I need to know. And let's say I'm taking another map, can cook any recipe. So this is going to store to couple of things that I can prepare this recipe or not, yes or no. Apart from that, available items in the starting are going to have a list of all the supplies, maybe raw materials, not dependent on any other, yeast, flour, meat. After that, if I'm checking for any recipe, let's say bread, if I'm able to prepare that bread, I'm going to add that supply to the available item as well. Bread is also available. And can cook bread? Yes, I can cook. And if in this case, let's say I'm adding tea, I am running into infinite loop. If there is a loop, or we cannot go further, or we cannot achieve any dependent, let's say recipe A is dependent to B, C, E, and B is dependent on A. In this case, it is an infinite loop. B is dependent on A. B is already visited. These kind of scenarios we have to take care of. So if it is a loop, you can just return false. No, we cannot cook. And in the end, whatever recipe we can cook, that is true. That list we have to return. So what is our approach here? Our approach is definitely iterative. Visiting this graph, traversing this graph traversal, we can do either DFS or BFS. I most of the time prefer DFS. So I'll just start with the DFS from every recipe, and the recipe might be dependent on some other recipe or some other ingredient, it means it is all. If it is present, then return true. Recipe, and if that recipe we have not prepared earlier, then just check for that recipe. And we can do the memorization over recipe as well, whether this recipe, once the recipe we have already processed that, we can prepare yes or no. We'll just store it in the cache. Yeah, this much we have to do. It's a graph traversal, and keeping in mind that we are not stuck inside a loop, and the graph traversal means it's a linear operation with some number of recipes, and you can consider it V plus E, vertex plus edges. Now let's have a look on the code. If in case you are not able to understand it, I would recommend you to watch the videos on topological sorting maybe, and the graph traversal. Now let's have a look on the code. Here initially I have utilized a couple of data structure, taking a map to map is cookable, that whether a dish can be cooked or not. I'm storing this answer here, and this will also serve as a DP to us, like whether this dish can be cooked or not, can be prepared or not. Verify dish, this function is a DFS function. Okay, so this is one data structure, and another one is dish to index map. See, our adjacency is already there, that this recipe is dependent on these two items, this node is dependent to these two nodes. But when we are having another recipe in the dependency, bread is dependent to these two, sandwich is dependent to bread and meat, and how do we go to the dependency of bread? So that link, if we are able to give it to the prepare by our own, we'll be able to have a complete adjacency list. First of all, every available item is can be cooked, and then I am preparing this dish to index map, my adjacency is done and my initialization is done, and for every dish I have to verify, can I cook this dish or not, can this be prepared or not. For that I'm passing every single thing, and apart from that, new hash set. Why this? Because there might be infinite looping. So to tackle that, I need to keep track of the visited dish or already prepared dish. Now once we have verified that dish, then we can check in our data structure is cookable. If it is yes, add it to the answer, otherwise skip it. Now we come to our main DFS function. First of all, is cookable containing that dish. It means that dish is already checked. There is no need to go further, right? There is no need to go further in this DFS call. We can return from here. If that dish cannot be prepared, in that case, just add it in the data structure with the flag false, that I cannot prepare this dish. If that dish is already prepared, just return. If we cannot prepare that dish, let's just capture it and return. Otherwise, what we will do is, first of all, we will mark that dish and visit every single ingredient. We'll do the DFS to every single ingredient. And how do we get the ingredient list? Dish index map dot get the index, and in the components means ingredients, I'll just get the ingredients list. Those are the required ingredients, and just do the DFS in that manner. If after processing that dish, if we are not able to prepare any other, maybe let's say any other subsequent dish, we'll just put it in the data structure, capture it in the data structure. And in the end, what we have to do is, like whatever dish we received in this DFS function, we have done the processing, and after doing the processing, just capture it, whatever is the answer. And the answer will definitely be true, because none of the subsequent call has returned false. So this was the code. I had taken a couple of data structure to store the data and prepare the adjacency, and then did the DFS over this graph. And while doing the DFS, I just did the same thing, same manner we used to do in topological sorting. We have to keep track of the looping cycle in the graph. If there is a cycle, there is no further way. We just can't prepare that dish. Otherwise, yeah, we can check the nested dependencies. I hope you understood the approach. In case you get any doubt, you can comment down below, and I'm also going to attach the code in the description below for your reference. Thank you guys. Bye bye.